As we learn more and more inference procedures, your ability to use your AP formula sheet as a resource becomes more important. So let me point out some important helpful things for hypothesis tests on your formula sheet. On the bottom of page 1, you see something that says sampling distributions and inferential statistics, and in one of the boxes there was a confidence interval template. There's also a template for something called a standardized test statistic, and it says statistic minus parameter over standard error of the statistic. Now we've actually used this a whole lot earlier when we first started talking about the normal model. So if we are taking a sample from a population and we're just looking at the one sample, X could represent an individual data value from that sample, and mu and sigma are the mean and standard deviation of the population. Z tells us how many standard deviations X is away from mu. Now when we deal with sampling distributions, the sampling distribution of the sample proportion or the sampling distribution of a sample mean, then the formula becomes a little more complex, but it's the same basic idea. So instead of taking an individual value and comparing it to the population mean and seeing how far it was from the population, how many standard deviations it was from the population mean, I'm taking a sample p hat and seeing how far away it is from my population parameter. And of course, if we're doing a hypothesis test, that population parameter would be our p naught, our null hypothesis value for p. And then the standard deviation, or the standard error of the statistic, I should say, is this formula here. And we'll talk about that more in just a minute, where that is on the formula sheet. For a t model, for the sampling distribution of a sample mean, I'm comparing x bar to mu naught, the hypothesized value for the population mean. And the standard deviation, or the standard error, I should say, of the statistic is the standard deviation of the sample divided by the square root of n. Now, so if you know your statistic and your parameter, those go in the numerator, statistic minus parameter, and then the standard error of the statistic you can find on page 2. So if you're talking about a sample proportion, the standard error of the statistic is written over here. If you're talking about the sample mean, the standard error for the statistic is right over here. Now we did mention that the parameters for if I know the population mean, I'm going to be using that if I know the population proportion, I'd be using p in here, or p naught if I'm talking about a hypothesis test, my hypothesized value for p. If I'm making a confidence interval and I don't know anything about the population, then I use p hat here in the formula. But the same formula, just using whatever value we happen to know. So sigma of p hat, the standard deviation of p hat, is based on the population proportion. The standard error of p hat is based on the sample proportion. So we always use we always say standard error over here, but sometimes we're actually using the actual standard deviation if we happen to know the population. Now, what exactly is a test statistic? So the test statistic is the number of standard deviations between the population parameter at the center of the model and the sample statistic that is being used to test the hypothesis. So this tells me number of standard deviations, this distance here. The p-value is the area under the curve that is farther away from the center than the statistic is. Sometimes it's to the left, sometimes it's to the right, sometimes it's both the left and right put together if we have our alternate hypothesis being not equal to. But it's the area always to the outside of the curve, outside of where our test statistic is, our sample statistic. So test statistic is actually the measurement of the number of standard deviations between our population parameter and our sample statistic when we do a hypothesis test. hopefully that's helpful, and hopefully you'll be able to use your formula sheet more effectively now.